we have vapors and ideal gases, the similar sila in different forms. So, yung PVMRT mo, palagi mong magagamit. Okay? The energy in and the energy out. Okay, so sabi dito, all of vapors and ideal gas have similarity in forms and in their processes, all of the equations that are based on the characteristic equation of a perfect gas or on Joule's law, okay, are not generally applicable to vapors. But the general equation, so energy in, energy out natin doon, excuse me, have the potential energy entering at point 1, kinetic energy entering at point 1, as well as the internal energy at point 1 and the work of the non-flow plus the heat added is equal to the potential energy at point 2 as well as yung wala ng kinetic energy kadalasan kas we have now the internal energy and the workflow at point 2 and the work of the non-flow work. Okay. Wait, dito class flow work at 1 to. Okay. So, ang pinaka-equation class dito sa processes of vapor. So, we use the simple energy equation. So, kadalasan, neglected yung potential energy, kinetic energy natin. The workflow at the point 1 and the workflow at point 2. So, kadalasan class, we have the simple energy equation. Hindi ko na class i-derive. Andun yung derivation ito sa. Okay. So, we have now the Q1, we have the internal energy at point 2. Pati class yung potential energy pala neglected din. We have the internal energy plus the work of the non-flow work. So, okay. May mga limitation to class, but we need to, concerning the substance, so, applicable naman siya to the different processes of vapors as well as sa gases. Okay? So, balikan natin yung perfect gas equation sa PVMRT. Okay, so palagi nyo ito class isa ulo. The PVMRT. But here, kadalasan na natin itong magagamit na simple energy equation. Okay, sa processes of vapor. Okay, balikan ko lang. Okay, so the first one process is the constant pressure process. Okay, tinatawag tong constant pressure. Ano yung mga tawag dyan, class? That is ISO. Ano, class? Pag constant pressure line, ISO ano? Paki-chat nga. Tingnan nga kung may nagbasa ng module ko sa Thermo 1. Kahit nagbasa. Pag constant pressure process, class. Question mark. Okay, so that is isobaric process. That is correct. Okay. So, in a constant pressure process class, that is called an isobaric process. Okay. So, sa isobaric process class, so, papakita ko to yung PV and the TS diagram during the isobaric process. So, ano yung process niya sa PV and TS diagram niya? Okay. So, we have the PV. Okay. This is the pressure specific volume. So, ganito yung class ha. Ang magiging, pag sinabi nating constant pressure. Okay. Okay. Pag sinabing constant pressure from the word itself, pressure, ibig sabihin class, yung P natin is straight line. Ayan. Okay. So, constant pressure to class, your P is equal to C, constant from, for example, from point 1 to point 2, this is now a constant pressure process. So, eto class, this is F. and this is G. Ito class yung saturated liquid line, the saturated vapor line. So, yung sa gitna class, yung mixture natin or tinatawag natin na X. Okay? Yung quality natin. Okay? Next, sa TS diagram naman class, sa TS diagram natin, okay, sa TS diagram, we have here the TS diagram. So, sa TS diagram class, ito yung, highlight ko lang class ha, ito yung magiging pressure line mo, straight lang. But here in the TS diagram, so TS na, mali. Yung TS natin class, ganito. Okay. So, paano yung magiging constant pressure line? Bakit pinapakita to class? Kasi para pag na-draw na natin yung processes, i-connect natin yung mga processes, lalong-lalo na sa simple Rankine cycle. Okay. So, ganito class. Pag constant pressure, ganito yung magiging itsura niya sa TS diagram. Excuse me. From point 1, papunta ka dito sa point F, wherein that is the saturated liquid line. Straight siya class pagdating dito. Okay? And also, yung M natin, mixture. And this is the saturated vapor line. And this is now at point 2. Okay. For example, yung pressure natin is in 0.2 megapascal. So, ganito yun, class. Pag draino mo siya sa TS diagram, magiging ganito siya. Okay. Ayan. So, this is now your pressure line. Bawa 0.02 MPa. Okay. So, ibig sabihin, kung yung given sa'yo nag-fall saturated liquid line, dito yon F at a given pressure. Okay? So, this is now your constant pressure processes. So, ano yung class yung mga kadalasang equation na ginagamit natin sa constant pressure line? Okay? Okay. So, kadalasan class sa PV diagram, paano natin nakukuha yung work as well as yung heat? Okay. Sa PV diagram class, ito natin. Sa PV diagram class, ito. Ayan. Pakilakihan natin. Tandaan nyo to class ah. Sa PV diagram natin class, in a constant pressure, ayan. In a constant pressure class, pag constant yung pressure niya from a wet mixture to that point, from point 1 to point 2, so makikita niyo to, this shaded portion, shaded. So, shade natin siya. Ayan. This one, the shaded portion, when it comes to PV diagram class, from point 1 to point 2, this shaded portion is called the, anong tawag sa kanya? This is now the integral of P dV. Bakit? Ibig sabihin, class, the work of the reversible non-flow constant pressure process. So, this is now your work of a reversible non-flow to class. Non-flow constant pressure process. Ayan, para maintindihan niya. So, in short, this is the work of the non-flow reversible process. Okay. Ibig sabihin, class, in a constant, ulitin ko, in a constant pressure process or the isobaric process, this shaded portion now is the work of the non-flow, which is equal to the integral of P. Di ba class, pag nagkukuha tayo ng strip, di ba? In your integral calculus, dV. Pag kumuha ka dyan ng isang strip, okay? So, if the constant pressure, given sa atin yung pressure natin constant, pag constant baga class, automatically lalabas mo siya dV. Diba? So, we have now the formula in the work of the non-flow at a constant pressure. So, pressure specific from point 2, kasi we have given points 1 to 2. Okay? So, V2 minus V1. Okay? This is now your work of the non-flow in a constant pressure. How about for a steady flow process? Okay. Pag steady class, babalikan mo yung, how do you call it? Babalikan natin yung sa energy in, energy out natin. Okay? So, this is your work. Letter B natin. Ito yung letter A natin. The PV and the TS. Letter B, work of the non-flow. Okay? For the steady process class, steady flow process. So, iba din class yung work doon. Okay? So, balikan natin yung general equation sa thermo. We have the work of the steady. So, may iwan sa atin is the enthalpy. H1, H2 minus the Kelvin plus the Q. Okay? So, depende na lang to class sa ating general equation. Mamaya, magsasolve tayo. And also, the transferred heat. Sige class, pakita ko lang sa inyo. Or the Q. How about sa PV diagram class, work yung nakukuha natin. But here, in TS diagram. So, this is now your TS diagram. Balikan nyo yung TS diagram natin. Okay. Tabingi na yung madrawing ni ma'am. Okay, so we have now the point. Red yung gamitin natin para mas matingkat. And we have here, this is the constant pressure line. Ganito baga class, diba? From point 1 to point 2, for example. Okay? Yung shaded portion class dito. Ayan. Yan. So, this is now your shaded portion. Pag sa TS class, this is the heat. Okay? Yung shaded portion natin is the heat. Okay. So, from the simple energy equation, kanina natin, we have this general equation. Internal energy plus the work of the non-flow. So, eto na class yung formula natin. So, for steady and non-flow processes, okay, for steady flow to class, steady flow and non-flow processes, balikan natin Q, internal energy, minus U1. Plus yung work natin class sa non-flow in a constant pressure, balikan nyo to. This one. Ito class, oh. So, yung work non-flow natin kanina, pressure times the specific volume or the volume at point 1. So, we can use also here, since dalawa yung given points natin, pressure 2. Kasi constant naman lang siya. We can use this formula. So, 2V2 minus P1 P1. Okay. So, general equation class. We all know, pag binalikan nyo sa thermodynamics, we all know that this is the general formula. Okay, wait, class, may nagpapa-admit. Okay. So, So, we have now the general equation. Yung enthalpy, balikan niyo ko sa termo. Termo 1 na hindi ko naturo. Q is equal to H2 minus H1. Okay? Kasi ito class, di ba, we have general equation. H is equal to U plus PV. Balikan nyo to. Okay? So, this is now your transferred heat when it comes to the constant pressure processes. Okay? Pag constant yung pressure processes natin. If the change in a specific internal is desired, we can use the relation. Pwede naman class gamitin natin to that the U2 minus U1 is equal to H2 minus P2 V2 minus H1 minus P1 V1. Okay, so ito yung babalikan nyo class. Here, the H is equal to the U plus PV. Okay? So, yan class yung makikita natin. So, this is just an example of the constant pressure process, the isobaric process. Okay? So, ano yung example natin dito? Okay, so paano natin makukuha yung mga pressure processes? Okay? Sige, mahaba-haba to. Sige, let's try. Okay, example. Anong gusto nyo? Yeah, ito na. If we have example, so example muna tayo sa constant pressure processes. So, sabi dito, number 1. Steam with a specific volume of 0.09596 cubic meter per kilogram. Okay, undergoes a constant pressure process at given 1.7 megapascal until the specific volume becomes, okay, madami-dami na class, 0.13796 cubic meter per kilogram. So, what are the letter A, the final temperature. Letter B, the change in internal energy, the work. The letter D, the change in entropy. And E, the transferred heat. Okay? So, ano yung solution natin? First class, we all know that this is a constant pressure and TS diagram. But first, hindi natin madodraw. Pag ganito class, pag nakuha mo na, idodraw mo din yung PV and TS diagram plane kahit hindi ko sa question. Okay? At the end of the process. Let's start using the steam table. Okay. So, ano yung given sa atin class? Ay, sorry. Ayan. Ano yung given sa atin? Black na yung gamitin. Okay. So, yung constant pressure natin is the pressure 1 is equal to pressure 2 kasi constant pressure. Yan yung tatandaan mo, constant pressure process. So, the pressure 1 is equal to 1.70 megapascal. Also in pressure 2. Yan. So, dalawa na. Ang given sa atin yung specific volume at point 1 which is 0.09596 cubic meter per kilogram mass. And also yung specific volume at point 2, yan, 796 cubic meter per kilogram mass. Class, masyado ba mabilis si ma'am? Hindi naman. Mabilis ba? Okay. Bibilisan ni ma'am kasi madami-daming kukunin. Okay. Sige kailangan ko yung cooperation nyo para madali tayo. Okay. So, punta tayo sa pressure. We're in saturation pressure. Punta kayo doon, class. Pressure 1.7. At pressure 1, which is 1.7 MPa. Okay? Anong table? 1.7 MPa. We have here, okay, table 2, page 11, that is correct, 1.2, 1.7. Okay, so what is the first thing we will need to evaluate? Ano class yung hahanapin muna natin? Given sa atin yung specific volume at 0.1, so make sure, okay, this is the given. So that is the given at specific volume. Okay, class, we have now the specific at volume. So ito class yung sinasabi ko na specific volume given. Given, kumpletohin nyo. Okay. So makikita nyo sa table that table 2, page 11, yan, para mas maintindihan ng ibang classmates natin. Okay, we have the specific volume, the saturated. Okay, we have 1.1634 times 10 to the negative 3 cubic meter per kilogram. Tama ba si ma'am? Ay, VF to class. Naduling si ma'am. This is the VF. Pasensya class, naduling si ma'am. VF, this is the VF. Ayan. So, this is the VF. And yung VG natin, the saturated vapor is, ilan class? Nag-chat na ba kayo? Tingnan ko nga ako nagpa-participate. VF po, ma'am. Ayan. Thank you, class. So, VF siya. Okay? So, VG class, we have 116.73 times 10 to the negative 3 cubic meter per kilograms. Okay. So, yung given sa atin, class, ito class na VG natin, pag kinonvert natin, magiging 0.11673 cubic meter per kilogram mass. So, yung given sa atin is, ilan? 0.09596 cubic meter per kilogram mass. So, take note, alin yung mas malaki, class? Alin yung mas malaki? So, ibig sabihin natin, yung VF natin, mas malaki yung given, pero mas malaki naman yung saturated vapor natin or the specific volume at that point. Pag ganito, class, ibig sabihin, mixture siya. Nagpo-fall siya sa wet mixture. Okay. So, finding the different properties given sa atin yung yung specific volume at 0.1. So, ano na yung gagawin natin? Pag ganito, class, nakuha na yung wet mixture, automatically, hahanapin natin si quality. Okay. Saka natin kukunin si quality. Okay. Pero, based pa rin doon sa table 2. Ha? Doon pa rin kayo kukuha sa table 2, page 11. Okay. Ang given sa atin is the specific volume. So, ano yung unang gagawin natin? Balikan mo. Yung specific volume at 1 is equal to, ano class? Equal siya sa VF plus X VFG at 0.1. Specific volume natin, ayan sa steam table mo yun class makukuha. at 0.1 minus VF at 0.1. Okay. Nasusundan ba si ma'am? Pinapakita ko lang yung paano pagkuha ng quality. Okay. Ito class na V1. Ito yung gagamitin class ha. Ito na given. Okay. V1 minus VF1. Itong VF1, this is the VF1 and the VG1. Yan na. This is now your pag sa mixture class. Excuse me. Over the VG1 minus the VF1. Okay. Yung quality mo, paano pagkuha ng quality mo? Yung V1 mo, ano yung V1 natin? V1 class. 0. Given yun class, 0.0. So, gagamitan 0.09596. Ayan ha, ganyan yung pag-present nyo ng answer sa akin class ha. VF1. 0. So, nerase na yan ni ma'am ha. 11634 cubic meter per kilogram. Sige class kayo, mag-solve na kayo. Pinapakita ko lang sa classmates nyo yung complete solution. Para hindi sila malito. 1173. Class, paksolve na ng ano? Quality. Ayan. Okay, what is now your quality? Ilan? 0. Okay, take note, always express your answer in percent. Asan yung calculator ko? Ayun, wait, class ko lang. Okay, nakuha na ba, class? Sigurado kayo? Double check nga ni ma'am. Okay. So, you can use 0.8203. Walang puntos yan kay ma'am because always express your answer in percent. Pag pinapahanap si quality. Okay. Okay. Move on. Anong pinapahanap sa atin? Madaming pinapahanap sa atin. The internal energy. We need also the enthalpy, the entropy, ayan, lahat pala kukunin natin class. Okay. Okay, first, we need to, paano makukuha yung, what is the next in the table, in the steam table? The internal energy at 0.1. So, how can we use that? Internal energy at 0.1. So, U1 is equal to UF what 0.1 plus the quality times the UFG at 0.1. Okay? Finding the internal energy at 0.1. UF1. What is UF1? Or the internal energy at saturated liquid? This is 870.09 kilojoule per kilogram. Plus yung quality class, ito na yung gagamitin mo. Yung 4 na decimal. Okay, ito. 0.3 times UFG. Gamitin nyo na class yun sa evaporation para hindi na kayo mag-minus. UFG, which is 1727.2. Ayan, ganyan class mag-present ng solution sa akin. We have now the internal energy at 0.1. Sige nga, baki-compute class. Internal energy at 0.1. Class, same table tayo ha. Table 2 pa din tayo. So, 870.09 plus something, 0.82.3 times 111727.2 28. Ilan may nag-answer na ba? 28 Okay? Ayun, 2286. Tama. 2286.9. So, what do you want, class? 2 decimals na lang tayo. 2 decimals na lang, class. 91 kilojoule per kilogram. 2 decimal, class, pag ganito, sa mga enthalpy, but when it comes to quality, 4 decimal tayo, ha? Naintindihan si ma'am? Yes or no? Raise your hands. Okay. Naintindihan na. Pag sa quality, we will use the 4 decimal rule, but when it comes to this one, 2 decimal. Okay. Move on to the next. We will find the enthalpy. Enthalpy, class. Enthalpy at point 1. Use this. At point 1 and the quality HFG at point 1. Same table, 1.7, we have the HF, we have 872.06, naduduling ba si ma'am? Hindi man. Kilojoule per kilogram plus 0.8203. HF, HFG, or the latent heat of evaporation, 1923.6 kilojoule per kilogram. So this is now your H1. This is your H1. 872 plus 0.8203. 03 times 1923.6. What is your answer? Okay. We have 9.99 kilojoule per kilogram. Okay. So, lahat ng andito sa steam table, hahanapan natin, class, ha? That is the first, the U1, the H1. Next, proceed tayo sa H1. H1, tapos na. Entropy. At point 1, we have the saturated liquid line, the entropy at the liquid line at point 1 plus the quality times the latent heat, evaporation, or yes, SFG at point 1, we have now 2.3718. Ano yung unit ng entropy? Kilojoule per Kelvin plus yung quality natin na 0.8203 times SFG 4.0282 kilojoule per kilogram Kelvin. So this is now your entropy at point 1. Huwag kakalimutan yung unit, 2.37. Ayan. Ay, wow, ang bibilis naman. Ay, yun pala, class. Sa entropy, class, kadalasan maliit dito. Ang ruling namin sa entropy, okay, another rule. Another rule, makinig. So, 4 decimal din tayo, class, sa entropy. When it comes to entropy. Take note. Sa entropy. Okay? Ulitin ko. So, 2 decimal, pwede tayo dito mag 2 decimal, but when it comes to entropy, 4 decimal din po tayo. Opo. Kasi maliliit yung values ni entropy, nagva-vary po. So, maiiba po kaagad pag inano natin. 4 decimal po si entropy. Okay? Clear ko lang sa atin, my dear students. Okay? So, 4 decimal tayo doon times the quantity 4.082282. Okay? So, what is now your entropy? Tingnan ko nga sa chat. Ayan, 5 point. Okay. Ayan. Ayan. Thank you, class. Okay? Naintindihan yung ruling natin? 5.6761 kilojoule per kilogram Kelvin. So that is now your entropy at point 1. Okay, hindi pa tayo class tapos. Kasi yung pinapahanap sa atin is wala pa na tayong nakukuha. Letter A, final temperature. Ayan o, change. So wala pa. Punta na tayo sa point 2. Okay. So, given at sa atin, sa point 2 is this one, may specific volume na. Okay. Okay, at point 2. At point 2, we're in yung pressure natin constant, ilan? 1.7 megapascal. But sabi sa problem, it becomes until that specific volume becomes at point 2, 0.13796 cubic meter per kilogram. Okay, balik tayo dito sa steam table, sa table 2. Page 11. Okay. Tingnan nyo, class. Sa page 2, page 11, the entropy, I mean, the specific volume, kanina nakita natin is 116.73 cubic times 10 to the negative 3 cubic meter per kilogram mass equal to 0.11673. Okay? Makikita nyo, class, that the specific volume na given sa atin is greater than this. Automatically, that is now a superheated vapor. Okay, mas malaki yung given sa atin kaysa sa saturated. Ibig sabihin, nag-exceed siya dito. Ibig sabihin, superheated vapor na siya. Anong gagawin mo? Punta ka na doon sa, class? Punta na saan? Table 3. Vapor. Punta ka doon sa table 3. Anong hahanapin mo? Si 1.07. 1.7 megapascal. Page. Yan, nakuha na ni ma'am. Table 3, page, Page Okay. Sige, yung iba. Nakuha na? Nakuha na ng iba? Okay. Take note. We have now table 3. Punta ka. Pag naanap mo na table 3, page 44. Ang guide mo is si pressure at 1.7 MPa. 1.7. O, paano na? Ano na yung gagawin mo? Yun lang yung given sa'yo is specific volume. Okay? Diba, class? Makikita mo dito sa steam table, sa page, sa table 3, okay? Sa table 3, makikita nyo yung mga values. Yung values natin, when this one is converted into times 10 to the negative 3, this is 137.96 times 10 to the negative 3 cubic meter per kilogram mass. Okay. Doon sa table 3, makikita nyo sa taas si 1.7 and yung 10 times, 10 times, bakit baliktad? Okay. 10 to the negative 3. Hanapin nyo, class, si values na nagfo-fall sa 137. Okay. Ang makukuha mo is doon sa table. Ang guide mo, class, is si 1. Bakit ayun? Ayan. Para makita nyo, class. Ang magiging guide natin is si 137.96. Okay? Dito, sa table na to. So, makikita mo dun sa table is 136.21 and 139.44. And dito, this is now your saturation temperature. Anong makikita mo? Kapantay ni 136. This is 260. And this one is also 270. Okay. Ano yung tanong question number 1. So, kukunin ko na to lahat, class. Kasi mag-interpolate na tayo dito. Also, we have internal energy. 2707.7. 2725.9. The H 2939.3. The 6.7219. Ayan na. Bakit nilagay yan lahat ni ma'am? Kasi mag-interpolate na tayo para makuha natin yung mga values. Okay? The U2, the internal energy at point 2, the H2, and the entropy at point 2, and the saturated temperature at point 2. Okay? So, yan yung hahanapin natin. So, what is now, or you can now interpolate, class, using this. Okay? So, paano yung pag-interpolate natin? You can use this general formula. Sabi ko nga, A, B, C, and Y, X, Z. So, B minus A, C minus A. Yan, B minus A, C minus A, X minus Y, Z minus Y. Okay. First is yung palagi natin sa right side kasi yung given sa atin is yung specific volume. We can use now the first equation sa interpolation. 137 minus 136.21 cubic meter. Pakita pa rin, class, yung units divided by 44 minus 0.13621. Ayan. So, this is now your basic. So, dito sa kabila, yung T2 is equal to 260. 270 minus 260. Unit, degree Celsius, degree Celsius. Okay? So, ano, class? What is now the temperature at point 2? Wow! Automatic? Sige nga, try din nga ni ma'am siya. 0.13796. Yung iba, bakit hindi nagka-solve? 136.21. Okay, 0.13944 minus 0.13621. On the right side, shift store A. Okay. 260 minus 270, 10. We have 265. 265 point. Ayun, lahat na yung sinolve, ha. Magaling naman, Okay. 42 degrees Celsius. So, we have now the temperature at point 2. Yan, lagay natin dito. 265.42. Okay, gawin nyo na. Solve also in the finding the internal energy. Sa internal energy, class, using the interpolation. Sige nga. Ayan, nakastore na yung ano ko. Ayan, minus 2707. Okay, 2725.9. 707.7. Shift store. What is your U2? Oh, mabibilis. 2717.56. Thank you, class. What is the unit? Kilojoule per kilogram. Okay. Pagkakalimutan ng unit. Units are units. So, may points yan. Hindi ko consider pag wala yan units. Okay. Kilojoule per kilogram. Okay, balik tayo. Enthalpy at point 2. What is now the enthalpy at point? Oh, ang bibilis Alpha A. Alpha A. Okay. Minus. Class, kayo na lang maghanap ng hacks kung paano kayo madali mag-interpolate. Siyempre, hindi yun sasabihin ni ma'am. It's for you to discover. Okay? 2939.3 minus 2963.63 minus 2939. Ayan. Ayan, may units na sila. Thank you, class. 2952. Very good. 2952.14. Okay. And last but not the least, the entropy. Sa entropy class, use the 4-decimal rule. Okay. 2952.14 kilojoule per kilogram. Okay, entropy. Sige, pabilisan. Si Madam ngayon, aluyod mag-compute. Ayun 6.68. 68.949. Ngayon, best friend nyo si steam table and si calculator nyo. 39. Okay, that is 6.7088 kilojoule per kilogram Kelvin. So we have now, 6.7088 kilojoule per kilogram Kelvin. Okay. Wala pa tayo pas na solve sa mga pinapahanap. Kinuha lang natin yung state points or the state points at 1 and the state points at 2. Okay. So, ano yung tanong sa atin sa letter A? What is the final temperature? So, the final temperature, since we already solved that is equal to temperature at point 2, which is 265.42 degrees Celsius. Okay, in letter B, find the change in internal energy. So, the change in internal energy is equal to U2 minus U1. U2 is 2717.56 kilojoule per kilogram minus U1. Balikan ni ma'am. Ay, hindi natin sinolve. Ayun. 228691. 22. Ayan. Pakisolve nga. What is the change in internal energy? Units. Huwag kakalimutan yung units. Units. 2756 minus 2286.91. Okay. This is 430.65 kilojoule per kilogram. Yan. Thank you, class. Letter C. What is asked in letter C? The work. Okay. How do we compute for the work? How about the work, class? Since we are in a non-flow work, the work is equal to the constant pressure times the specific volume at point 2 minus the specific volume at point 2. Okay? 1.7 mega. Take note of the word megapascal. Specific volume at point 2. 137. Oh, wait. Okay, 137.96. Am I right? Even yan, class. Cubic meter per kilogram minus specific, given yung specific volume natin. This is 95.96. 95.96 times 10 cubic meter per kilogram mass. So, what is now your work? And the units. Sige nga. Kadalasan dyan nagkakamali ang mga estudyante ko. Take note, megapascal and kilo. Dapat ang pascal ba class, that is in Newton per meter squared. So, ang answer kadalasan is in Newton. 37.96 minus. Oh, bakit nag-arrive dyan si ma'am ng answer? You have to convert your megapascal into kilojoule. Para class 1 megapascal is equal to 1,000 kilopascal. Okay, so makukuha mo na yan. Huwag kakalimutan yung times 10 to the negative 3. Ha? Na decimal yon. Okay? That is letter C. How about in letter D? Constant pressure lang tayo, class ngayon. Letter D, what is the change in entropy? Entropy. So, we have the change in S. S2 minus S1. The entropy at point 2. Ayan, 6.7888. 6.7888 kilojoule per kilogram Kelvin. And this, the entropy at point 1, 5.67. Tama ba ako? 67, 61. Ayan. Oh, compute for the change in entropy. Ayun, may answer na sila. 788 minus 5.67, 61. Okay? This is 1.0327 kilojoule per kilogram Kelvin. Okay? Intindihan ba, class? And letter E, last but not the least, we will find now the transferred heat wherein sa constant pressure. Tandaan nyo to, class, ha? The Q can be used as the enthalpy at point 2 and the enthalpy at point 1. Okay? Take note of that. We have now here the Q. So, H2. Ano, saan yung H2? 2952.14. 2952.14. Don't forget the unit minus H1. Ayun, 2449. 2449.99 kilojoule per kilogram. So we have now the transferred heat. Ilan? 2952.14 minus 2449.99. Okay, so we have now the transfer heat 502.15 kilojoule per kilogram. Okay, class, may question pa ba sa ating molecular chart and the first process of vapor wherein that is now the constant pressure? Okay. Naintindihan ba, class? Baka hindi nyo naintindihan. Okay, class, naintindihan po ba? Yan. Wala na po bang question, class? So, ganun po class sa constant pressure. Isa pa lang po to class. This is the constant pressure. Okay? Constant pressure process. Okay? So, if you don't have any question, then PM na lang si ma'am.